Video we're going to talk about how to make alkynes. So what if I give you this molecule and I add sodium hydroxide? All right, what will be the products? Well, the products will look something like this. Carbon that has a negative charge but plus water. The pKa of water, right, is about 16. pKa of this molecule is about 25. So which side does the equilibrium favors? All right, favors the weaker acid, right? So in this case, the EQ favors the reactant, right? So in other words, this reaction will not go forward, right? Now, what if I were about to take the same molecule and add sodium amide, right? What will I get? The products will look something like this. Carbon with a negative charge plus ammonia. Now the pKa of ammonia is 38. The pKa of this is 25. Equilibrium favors the weak acid, right? So EQ in this case will shift to the product side. Right, remember, the higher the pKa, the weaker the acid, right? So here's a takeaway. In order to make alkynes, you need a very strong base, very strong base. Yes, sodium hydroxide is strong, but it's not strong enough. So sodium amide, NaNH2, is your go-to guy. This will get the job done. Right? So let's talk about the how to make alkynes. All right. So what if you have a molecule like this? You have two bromines here, right? You take sodium hydroxide in the first, sodium hydroxide, ammonium, all right, sodium amide in the first step, and you have to add water in the second step. And we're going to show you reason why you're going to have to add water. So I want you to think of sodium amide as some sort of NH2 minus, with the minus belonging to the nitrogen. So remember, we have two hydrogens here. So in the first step of the mechanism, because it's such a strong base, it's going to eliminate. So it's going to come take off this hydrogen, kicks in these electrons, and then kick off one of the bromines, right? So you'll get an intermediate that looks something like this. With a bromine here, still have one hydrogen here, right? So you'll get an intermediate that looks like this. Then simply another molecule of NH2 minus comes in, take this hydrogen off, kicks in these electrons, and kick off that bromine, right? And you get something, and I'm going this way with the reaction, and you get something that looks like this. Right, you get something that looks like this. Right, you get something that looks like this. Now, because sodium amide is so strong, what it's going to do again, another molecule is going to come in and act as a base, take this hydrogen off, kicks off the electrons on that carbon right there. And notice that my triple bond is drawn linear, right? 180 degrees, right? So you'll get something that looks like this. Maybe I should really draw it 180 degrees, right? So you'll get something that looks like this with a carbon with a negative charge. That's how strong sodium amide is. But this is why we add water. And in the last step of the mechanism, all right, sodium the molecule now, this negatively charged a carbon, anion, comes and acts as a base, kicks out these hydrogen, kicks out the electrons on the oxygen, and you get your neutral product to be something like this. All right. So this is how we make alkenes. So sodium amide is going to become very important when we talk about alkene synthesis.